Hello and welcome to the 1-2 video on order of operations and evaluating expressions. This is video 1 of 3. Our objective for this lesson: I can use the order of operations to evaluate expressions. Before we actually do some evaluating, let's take a second to clean up some vocabulary misconceptions. We can use powers to shorten how we represent repeated multiplication. A power is broken up into two parts, a base and an exponent. The exponent tells you how many times to use the base as a factor, so it represents repeated multiplication. So if we look at the power 2 to the 5th, the base is 2, the exponent is 5, and that means take 2 and multiply it by itself 5 times. We can read exponents of 2 as squared, so we could say, 5 squared instead of saying 5 to the second power. And we can read an exponent of 3 as cubed. We can simplify a numerical expression when we replace it with a single numerical value. Please note that algebraic expressions can be simplified to a given point, but you won't be able to simplify an algebraic expression to a singular numerical answer unless you know what that variable value is. So, PEMDAS, it is an acronym to help you remember the order of operations, and it's wrong. Because it implies that multiplication goes before division and addition goes before subtraction. And that's not true. What's true is multiplication and division actually happens simultaneously, and addition and subtraction happen simultaneously. You do both of them as you move through the expression left to right. So if you had a problem that had a division between two numbers and then a multiplication of two numbers later on, because we read math left to right, we would do that division before the multiplication, even though in PEMDAS the M comes before the D. Multiplication and division are two sides of the same coin. Same thing for addition and subtraction. So you got to make sure that you're doing that, otherwise you could misevaluate. Now, before we actually evaluate some things, there's one more idea here, and that's the idea of negative bases and exponents. If we have a number that has a negative in front of it and it's being raised to some exponent, they are sometimes equal and sometimes not equal, depending if there's parentheses around the non-exponent part. I'm being very careful here with the vocabulary. This can sometimes be true, but is not necessarily true. So, on the first example, with the 5s on the bottom left, we see a negative 5 squared with no parentheses, and I'm claiming that that is not equal to negative 5 squared. And that's because negative 5 without the parentheses really means, according to the order of operations, you do exponents before multiplication. That negative in front really means, hey, multiply by negative 1. So you don't read the negative 5 squared as negative 5 squared. If it doesn't have parentheses, you actually read it as the opposite of 5 squared. Negative 5 squared implies the parentheses because the base with the parentheses is negative 5. The base without the parentheses is positive 5. So negative 5 squared is not equal to the opposite of 5 squared. And we can evaluate and see why. So negative 1 times 5 squared, you do 5 squared first, right? That's 5 times 5, and then multiply by negative 1. Negative 5 squared is just negative 5 times negative 5, so nothing interesting going on there yet. Negative 1 times 5 times 5 is 25, and then negative 1 times 25 is negative 25. But on the right side, for negative 5 squared, negative 5 times negative 5 is positive 25, and so we do not get the same answer. So the opposite of 5 squared is not equal to negative 5 squared. We can see the exact same thing over here with the 0.2. So the opposite of 0.2 squared versus negative 0.2 squared. So that means negative 1 times 0.2 squared on the left-hand side for the opposite of 0.2 squared. And on the right-hand side, our base is negative 0.2 because it's in parentheses. And so that is negative 0.2 times negative 0.2. If we evaluate that using order of operations, 0.2 times 0.2 is our 0.2 squared, and then we get 0.04, multiply that by negative 1, and we get negative 0.04, while negative 0.2 times negative 0.2 on the right-hand side is positive 0.04, because a negative times a negative is a positive. So we do not get the same value. So sometimes this is true. Negative 10 cubed is equal to the opposite of 10 cubed, and here's why. Negative 10 cubed, the base is negative 10, because it's in parentheses. So that's negative 10 times negative 10 times negative 10. Order of operations, we multiply left to right. So negative 10 times negative 10 is 10 times that, or excuse me, is 100 times that negative 10. We get negative 1,000. The opposite of 10 cubed, we have that negative 1 times our base of 10 being multiplied by itself 3 times. 10 times 10 is 100. 100 times 10 is 1,000. But then we still need to multiply by negative 1. So we get negative 1,000. Negative 1,000 is equal to negative 1,000. So negative 10 cubed is equal to the opposite of 10 cubed. So depending on the exponent is going to tell you whether or not it's a true statement or not. That is going to determine whether or not you need parentheses. Let's do some actual order of operations simplification. So the group 6 minus 2 cubed divided by 2. Order of operations, say we do parentheses first. So 6 minus 2 is 4. We cube it. So that means 4 times 4 times 4, which is 64. And then after we've simplified what's in our parentheses and our exponents, we can divide by 2. We get a final numerical value of 32. So for our second one, 4 plus 3 to the 4th, all being divided by the difference of 7 minus 2, you have to know that fractions are implied groups. It is the numerator divided by the denominator. So before we're allowed to do the final division of the fraction, because a fraction is just glorified division, we have to simplify that numerator to just a single value and that denominator to just a single value and then divide. So our numerator, 4 plus 3 to the 4th, is going to be 4 plus 3 times itself 4 times. Denominator is still 7 minus 2. 3 times 3 times 3 times 3. Well, that's 3 times 3, which is 9, times 3, 27, times 3, 81. So our numerator is 4 plus 81, which is 85. And then the denominator is still 7 minus 2. We could have simplified that 7 minus 2 at any point. Doesn't really matter. But we get 85 over 5, and then we divide. And we get a final answer of 17. 2 to the 4th minus 1 all over 5. Again, we have to simplify that numerator before we divide. So 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 minus 1, we get 15. And 15 all over 5 is 15 divided by 5, which is 3. And then our last one, 5 times 7 divided by 2 being distributed into the group of 3 plus 1, but that group is being squared. So lots going on here. What do you do first? Well, we need to simplify the parentheses first. 3 plus 1 simplifies to 4. And then we have to do the exponents, right? Parentheses, then exponents. So 4 to the second power, please note that that 2 in the front is not part of the base. The base is 4 because of those parentheses. So 4 times 4 is 16. And so we now have 5 times 7 divided by 2 parentheses 16. Well, what does it mean for a number to be next to a parentheses? Well, that's implied multiplication. So this is 5 times 7 divided by 2 times 16. 5 times 7 is 35 divided by 2 times 16. And we're just going to work left and right, right? Multiplication and division are all on the same level, different sides of the same coin. So 35 divided by 2, we get 17.5, and then 17.5 times 16, we get 280.